Hi, future doctors. Welcome to the next class. In this class, we will see what is apparent weight and Archimedes principle, what he said. So, according to Archimedes principle, if we are filling any liquid in a vessel or glass, if you poured water, some object you have placed inside the water. At the time, it is going to be immersed, let us assume. Some part of water is going to be coming outside of this glass. Now, what he said means the loss of weight of this object is always equal to weight of this liquid displaced. Whenever this liquid is going to be displaced, it will be coming outside. So, how much liquid is going to be getting displaced or which is coming outside? So, displaced means here, according to him, if it is up to here, let us assume it is rising up to here. This is displaced liquid. So the loss of weight of the object is always equal to weight of the liquid displaced. According to this is only we are equating it as buoyancy force. What is the buoyancy force? We said FB is equal to dl Vg. V is volume of the object. dl is density of the liquid. Next, here we will be having density of the body. By using that, we are going to get apparent weight. So what is the apparent weight means formula? Normal weight of the object in air. Whenever it is going to be in air, what will be the weight? We will say mg minus, so loss of weight, that is only equal to buoyancy force. What is the buoyancy force equation? Mg minus dl Vg. So dl is density of the liquid. So m is mass of the body. Now this mass of the body they will write in terms of density of the body. Density of the body is mass per unit volume. Then mass can be written as dBV. So substitute the dBV here. So dBVg minus dLVg. So you can take common Vg. This equation also you can write it as apparent weight, no problem. So dB minus dl, density of the body minus density of the liquid. So if it is going to be immersed means we will say later loss of flotation, density of the body should be greater than density of the liquid. Then only it is going to be immersed, or what happens partially immersed. So immersed on the surface, we will say that is only loss of flotation. dB minus dl. So this dB, if we are taking common outside, dB Vg. How we will write this one means 1 minus dl by dB. So in mathematics, you will write a plus b. If you are taking a common, 1 plus b by a, same like that. So now dBV, what we wrote dBV here? dBV is nothing but, in place of this again they will write mg into 1 minus dl by dv. So this is the equation for apparent weight, mg into 1 minus dl by dv. Any object within the liquid, on that how much force you have to apply to pull it upwards means that should be equal to apparent weight. So, in properties of solids, we discussed if an object is suspended by mass, what is the elongation in air? We said means elongation in air is this mg is acting at L length, therefore mgl by ay. So, we wrote FL by ay form, mgl by ay. Now, same object as it is with this thing, if you immersed in a liquid. So, whenever you are placing this object inside the liquid of mass m, then what is the tensional force or what is the elongation in water? They will ask. At that time, same force will write, but mg into what will write here? 1 minus dl by dv. 1 minus dl by dv into L by ay. So in place of mgl by ay, what we can write? Elongation in water is equal to 1 minus dl by dv into elongation in air. So one formula, it is giving how many equations you will see. Next, if you want to pull this object outside of this liquid surface, if you want to pull this object outside of this liquid surface, how much work you have to do. So work formula, force into displacement. So what is the force we are applying means now? Apparent weight, mg into 1 minus dl by db. So you are pulling this one outside, displacement also outside, isn't it? So then displacement is nothing but height of this liquid. So that is the work done to pull the object. This is the elongation. In water means density of liquid, we will write density of water, isn't it? So like this, they will give problems. Apparent weight equation is going to be very, very important. Next, if we suspend object within the liquid, what is the tensional force is going to be developed within this string. So if you want to derive this equation, again you will be getting same thing. So mg is going to act downwards. On this tensional force is acting upwards. In addition to this, which force is going to act? Buoyancy force. Buoyancy force is going to act upwards. T plus Fb is equal to mg. Then T is equal to mg minus Fb. Again Fb, buoyancy force. So dl Vg, density of the liquid. So this is density of the body. Again, if you replace, you are going to get same equation. mg into 1 minus dl by db. Otherwise, density of body is mass per unit volume. Mass can be written as dBv. So some people will write this equation like this only. So how many equations you are writing? Yeah, just you are writing from apparent weight. So dB minus dl into Vg. This is the tensional force developed. Correct? Next, if we are pulling this entire beaker upwards with acceleration A. So whenever upwards, what we said? Tensional force. So mg, sorry, Vg. Mg also you can write. Mg means you have to write this equation. So we are writing final equation. This we are using in different way. So dB minus dl V, if it is moving upwards, tensional force G plus A. If it is moving downwards, beaker is moving downwards with acceleration A. At the time, same formula dB minus dl V G minus A. So if this beaker is moving horizontally with acceleration A, then again, so T is equal to dB minus dl into V. So what is this acceleration due to gravity? So horizontal acceleration, vertical acceleration G. So resultant acceleration is going to be root G square plus A square. Therefore, root of G square plus A square. Next, whenever you are moving horizontally, it is going to make some amount of angle. How much angle it is going to make? Same like previous one, in laws of motion we discussed, tan theta is equal to A by G. So that formula we are going to use here, isn't it? No, same thing. So they may give like this also. An object is suspended with a string like this in a liquid. So what is the tensional force at this time they are going to ask? Density of liquid, density of body. So whenever they gave reverse like this is going to be reversed. In place of dB minus dl, you will get dl minus dB. Again, you will get same formula. So derivation is not required. Directly we can write. If you write same equation also, no problem. Just you will get negative sign extra. That's all. Negative sign you are getting means tensional force is going to be reversed. So that reverse you are getting in the form of negative sign. So, but generally we will write like this dl minus db vg. Again upwards in place of g, g plus a. Downwards in place of g, g minus a. Horizontally same equation you will get. So if it is moving horizontally, what is the angle made by this? If it is moving horizontally, it will be shifting like this. How much angle it is going to make? Again same formula. Tan theta is A by G. So all these two are going to be similar, small change, that negative sign, dl minus dp, because here tensional force weight is going to act downwards, buoyancy force is going to act upwards. Here tensional force upwards, buoyancy force upwards. So the tensional force is reversed. It is going to give negative sign if you write db minus dl. So this is about apparent weight. So and the object suspended within the liquid.